So when counting from here to here, in uncommon 2, in uncommon 4 as well. So 2, 4 also die here. So either from left to right or right to left, we have the same thing. 1, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Cannot be another hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. So we have to name this. So we start from left to right, 3, 4. Can see 1, 2, 3, 4, 5. 3 straight. So it's not branch, still straight. Please take note of that. So in this case, the parent name is pen inspect. Inspect. 1, 2, 3, 4, 5. Inspect. So N attached to carbon 2. Between 2 and 3, I will take 2 first. Another N between 3 and 4, I will take 3. So die here. So we have seen pent 2, 3 die. So the chlorine attached to carbon 1. So it will be 1 chloro pen 2, 3 die. 1 chloro pen 2, 3 die. When counting from left to right, let's say right to left. So I will call this to be 1. I will call this to be 2. This will be 3. This will be 4. This will be 5. So the parent name still remain pens. Pens. So between 2 and 3, A is between 2 and 3. So I will take 2. Between 3 and 4, I will take 3. How many here die here? No problem with that. Then chlorine attached to carbon 5. So this will be 5 chloro pen 2, 3 die. So from here you will see clearly you have iron number here. 2 plus 3 plus this 10. This one you have 6. So this is correct. This is wrong. Please always take note of that. Number 9. Let's say you have 1, 2, 3, 4, 5, 6. You have in here, another in here. So this will be hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. You cannot have this. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You cannot have this. 1, 2, 3, 4. Please take note of that. So in this case, you have to name this. 1, 2, 3, 4, 5, 6. The longest is 6. The longest is 6. So that is X. X. 1, 2, 3, 4, 5, 6. So I want to count from left to right. 1, 2, 3, 4, 5, 6. So between 1 and 2, we have 1. X1. Between 3 and 4, I have 3. I will take 3. Between 5 and 6 carbon, I will take 5. 5. Making N. So we have N. So how many here now? 3. So it will be tri here. If you count from the right to left, 1, 2, 3, 4, 5, 6. So the parent chain is X. Then between 1 and 2, you take 1. In between 3 and 4, you take 3. In between 5 and 6, you take 5. It's also tri here. Either from left to right or right to left, you are going to get the same answer. The two are correct. This will mark the end of IUPAC nomenclature of alkene group. So the next thing is alkyne. Our class of organic compound is alkyne. Let's see alkyne. C triple bond C. That's the functional group. So let's see the general formula. The general formula of alkyne is Cla2n-2. So the first member, no member of alkyne with one carbon atom. So nothing like methyl. No. It's the first member start with one carbon atom, two carbon atoms. So which is the first member. So first member is ethyl. Is ethyl, meaning N is equals to 2. So the formula for ethyl will now be C2, 2 times 2, 4, 4 minus 2. So C2H2. That's the first member. That is ethyl. Structurally, it's carbon, triple bond, the hydrogen here. Hydrogen, you can see that is evenly distributed. 1, 2, 3, 4. 1, 2, 3, 4. That's why this is the structure of ethyl. So the second member of ethyl, be careful. In why? Because what is the name? Give the name of the second member of alkyne. You know, it will be when N is equals to 3. This you get. Don't say the second member, then you move to ethyl. Ethyl is the fourth member. So no member of alkyne with one carbon and no methyl. So the first member is when N is equals to 3. The second member when N is equals to 3. So it will be propyne. Propyne. That is Ca3. 2 times 3, 4, 4 minus 4, 2 times 3, 6. 6 minus 2 will give you 4. So structurally, first of all, put the triple bond. So then another carbon. Hydrogen, 1, 1, 2, 3, 4. Complete. 1, 2, 3, 4. Complete. 1, 2, 3, 4. This is the how to distribute hydrogen. 4. So the name here is known as propyne. Propyne. You can say 1, 2, 3, 4. That is propyne. Then 3. We have butane. Butane. You know, it will be C4. 2 times 4. 8. 2 times 4 will give you 8. 8 minus 2 will give you 6. C4H6. So let's see the structure. 1, 2, 3, 4. So one hydrogen will be here. 1, 2, 3, 4. 1, 2, 3, 4. More hydrogen again. 1, 2, 3, 4. 1, 2, 3, 4. So it will be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Count it. 1, 2, 3, 4, 5, 6. That's why we have 6. So this is a butane. That is normal butane or but1I, or we call it but1I. Take note of that. Or we call it but1I. But1I. This one can be written as a prop1I, prop1I, and so on and so forth like that. So number 4. Let's see, you want to write the structure of octane. You know, to be C8, 2 times 8, 16, 16 minus 2, be 14, 14, 5. Let's say you want to write the sign. That is C10, 2 times 10, 20 minus 2, 18. So 6 equals sign. Equals sign. This will be C20, H38 when you apply the formula. When you apply the formula. And so on and so forth. And so on and so forth. This is a straight one. straight one. This is normal. Remember, you can, instead of this, you can say this is something like oct1i, oct1i, or dec1i. Then when it is branched, or the position of I is changed, how do we name it? That's the next thing. If the position of I is changed, always remember for alkyne, it is triple bond, and this is the general formula. And that's the general formula, and it's a triple bond unsaturated hydrocarbon. Unsaturated hydrocarbon. First, before we move to branching, let's see question. Name a member of alkene of alkyne with the formula CxH14. Name a member of alkyne with the general formula CxH14. H14. So what we are going to do here is use the general formula. Solution now. Solution. That's question 1. The general formula of alkynes is CnA2n minus 2. You know, this one is given is X. We don't know, so we need to look for it. But N, which is equivalent to N, but 2n minus 2 is equals to 14. So when you compare, therefore you can say 2n minus 2 is equals to 14, and n is equals to x here. X is equals to 12. So here you can say 2n is equals to 14 plus 2. 2n is equals to 16. n9 is equals to 16 divided by 2. n9 is equals to 8. So x is equals to 8. So the molecular formula, the molecular formula of the member is CH14. Bearing the name, and the name is, this is a octane. Octane is the name. That is question 1. Question 2. The ratio of atoms of carbon, the ratio of atoms of carbon to hydrogen in alkyne is 4:7. Is 4:7. Find the molecular formula of the alkyne member. Is CnA2n minus 2. That's the general formula of alkyne. So the ratio of carbon N ratio 2n minus 2 to hydrogen is going to be 4:7. So it will be n all over 2n minus 2 is equals to 4 divided by 7. Let's multiply 7n is equals to 4, 2n minus 2. 7n is equals to 8n minus 8. 7n minus 8n is equals to minus 8. Minus n is equals to minus 8. n9 is equals to 8. So we have gotten our n to be 8. So put it here, molecular formula. The molecular formula will be C8 2 times 8, 16, 16 minus 2. That is 14. That's the name. So you can see it's also butan. Take note of that. Take note of that. Maybe I should give you another example. Question 3. The relative molecular mass of alkyne is 40. Find the molecular formula. Find the molecular formula of the alkyne and hence name it. Give the IUPAC name. The general formula for alkyne is Cn into n minus 2 is equals to relative molecular mass. So 12, carbon is 12, then 12n plus hydrogen is 1 times 2n minus 2. Hydrogen is 1, mass number is 1, while that of carbon is 12. So this one is going to be 40. So 12n plus 2n minus 2 is equals to 40. This one is the 14n is equals to 40 plus 2. 14n is equals to 42. n9 is equals to 42 divided by 14. n9 is equals to 3. So the molecular formula is, apply the formula, C3 H 2 times 3 4 6 6 minus 2 4. That's the name. So the name, you have to name it. The name is propine. It has 3 carbon atoms, so call it propine. So let's move straight to naming of branched chain alkynes with branching or with the position, or by changing if the position of a triple bond is changed. It's no longer between carbon 1 and carbon 2. It's now changed. It's placed elsewhere. Then how do we name it? We still call it under branch. So please take note of that. If I say branch, take note of that. So example 1. Let's say number 1. Example 1. If you are given something like this, you have the triple bond. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. Equation is that is a balance. 1, 2, 3, 4. 1, 2, 3, 4. You cannot add hydrogen again. You know, this can be written as C4, 1, 2, 3, 4. This is C4, molecular formula C4, H, 1, 2, 3, 4, 5, 6. That is H6. Take note of that. Then how do we name this? The same thing. Dependent on 1, 2, 3, 4. Either you are counting from left to from left to right, 1, 2, 3, 4. Right to left, 1, 2, 3, 4. So it's 4. So it's boot. Boot. So let's see I. 1, 2, 3, 4. Between 2 and 3. So you take 3. So boot 2 I. That's boot 2 I. If you are counting from right to left, 1, 2, 3, 4. You can see it's between 2 and 3. So you take 2, 2. So you still boot 2 I. Either from left to right or right to left. Take note of that. Let's see number 2. You are giving 1, 2, 3, 4, 5. And so on like that. I do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You can see how hydrogen is being distributed. Take note of that. So like this one now is, let me count from left to right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is X. This is X. This is X. So between carbon 1 and 2, I on carbon 1, I will take 1. Between this one is between 4 and 5, I will take 4. So comma 4, then di I. That is counting from left to right. From right to left, let's see. 1, 2, 3, 4, 5, 6, 7. So we still have 8. 8. So I is between 3 and 4. So I will take 3. I is between 6 and 7. I will take 6. So it will be di-I. 8, 3, 6 di-I. So this one is 1 plus 4, 5, 3 plus 2. This one is wrong. This one is correct. So it's 8, 1, 4 di-I. So let me call this to be A. Let me call it to be A. The same, let's say you are giving the molecular formula CH, you are giving C, CH2, CC, CA2, CA3. You have to draw the structure and to name it. I will say hydrogen here, another carbon, hydrogen, 2 hydrogen, another carbon, then hydrogen here, then another carbon, then 3 hydrogen. That is what you have. And remember, carbon is tetravalent. You have to check. And you cannot add hydrogen, you can add bonds. So here we have 1, 2. It's not complete. So 3, 4. I'll continue. 1, 2, 3, 4. You cannot add. 1, 2, 3, 4. You cannot add. 1, 2, 3, 4. You can see. Here for this carbon now, 1, 2, 3, 4. You cannot add. 1, 2, 3, 4. You cannot add. 1, 2, 3, 4. Then you then name it. Please take note of that. If you are giving something like this, give the structure. Then if you have to name it, you count from left to right, right to left, which we have done. Like this one now, if you count from left to right, 1, 2, 3, 4, 5, 6, 7. That is 8. 7 is 8. in on carbon 1 and 2, you take 1. Another hine on carbon 4, you take carbon 4 and 5, you take carbon 4. Then dihine. At 1 for dihine. That is what you are giving. That is what you are. Let me say C. Let's say you are giving at 1 for dihine. And you have the structure. Always start with the family name, parent name. So that X. 1, 2, 3, 4, 5, 6, 7. 7. High is on carbon 1. So triple bond on carbon 1. Then another high on carbon 4. Carbon 1, 2, 3, 4. Take note of that. It's not here. It's here. Or carbon 4. 1, 2, 3, 4. That's all. Then complete your hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you may be giving the molecular formula to draw the structure, and then you may give it the name to draw the structure. Please always take note of that. So let's see example 3. Example 3. You are giving 1, 2, 3, 4. Between here you have, okay, one, two, three. You have hydrogen here. You have hydrogen here, hydrogen here, hydrogen here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1. So that is the structure on the board. You can see there are 2 functional groups. We have in alkene and alkyne, and in this priority. This one is above A, so alkyne is above A. Take note of that. So if I want to name this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is a pent. So if I'm counting from here, 1, 2, 3, 4, 5. It will be pent 1, pent 1 I. That is 1 I. Before we and 3N, between 3 and 3N. That is what you have. How do we now combine the two together? So always make sure that I supersede A. So I must have lower number. Always take note of that. So this is the pent 3N 1 I. Pent 3N 1 I. Let's, when you are reading it in this form, let's count from I've considered from right to left. Let's see left to right. 1, 2, 3, 4, 5. This will be pent 1 and 2, 2 and 3. That is we are going to take 2 and 3. So 2 and then between so between 4 and 5. So we are going to take 4. Then 2 and 4I. 4I. This one is wrong. So this one is wrong. So this is the correct answer. So we have pen 3N 1I. Take the lower number for I. Let's count from right to left. 1, 2, 3, 4, 5. So we still have pence. Pence. So it's between 1, 2, 3. Between 2 and 3. So I'll take 2. That is pen 2I. Chlorine attached to carbon 1 here. So I'll say 1 chloro. So when you count it 5 plus 3 and 1 plus 2, we are going to get 3. So this is correct. This is wrong. So the answer is 1 chloro pent 2 high. Please take note of that. Take note of that. The last example I'll give you here. 1, 2, 3, 4, 5. We have methyl here. You have iron here. You have chlorine here. 1, 2, 3. Okay, let me make it longer. Hydrogen here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That is what we have. So let's see the longest. You can see from left to right. If you start 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So it's 7. So that is X. So this is 1, 2, 3, 4, 5, 6, 7. So triple bond is between 3 and 4. So I will take 3. Between 6 and 7, I will take 6. So that is dihine. That's the parent name. Dihine. So chlorine, methyl attached to carbon 2, while chlorine attached to carbon 4. So 5 chloro, it would be 5 chloro, 2 methyl. You can see? So it will be 5 chloro, chlorine on carbon 5, 2 methyl, 3, 6 dihine. When you are counting from left to right, let's say right to left. 1, 2, 3, 4, 5, 6, 7. 7. So we still have 8. So between carbon 1 and 2, so we'll take 1. High on carbon 1. Between 4 and 5, I will take 4. 4. This one will be dihine. So chlorine on carbon 3, while methyl on carbon 6. Chlorine, you can see it's on carbon 3, methyl, Ca3 on carbon 6. So chlorine on carbon 3, so it will be 3 chloro, methyl on carbon 6, 6 methyl, 814 dihine. So let's see which one is correct. Which one is correct? Let's add. This is 9, 10, 11. This is 16. This is 16. 7 plus 9. That's 16. This is 9, 10, 14. So this one is correct. This one is wrong. Please take note of that. Alkanol. Alkanol. The one we call alcohol. Alcohol. That is our next topic. Our next topic, yes. Naming IUPAC nomenclature of alkanol. You know the functional group, still remember COH, the functional group, and the general formula. The general formula of alkanol. That this common name is alcohol. So the general formula of alkanol is CnH2. A2N plus 1 OH. That's the general formula of alkanol. So next video we are going to see all the members of alkanol and the naming of alkanol.